Today I am going to teach you LRTF algorithm, longest remaining time first algorithm. LRTF algorithm is somewhat similar to SRTF algorithm, but the only difference is that in SRTF algorithm we select shorter jobs, whereas in LRTF algorithm we will select longer jobs. Okay, here longer jobs will be given more priority. Okay, and the rest of the remaining things are same. Okay, so it's better we solve one or two numericals. Okay, so you just see here and don't see this part. Don't see this. It's a separate question. Now for the time being, just focus here. Okay, and after solving this, I will come to this. So now just don't see here. Okay, so just see this question. You see arrival time. There are four processes: P1, P2, P3, and P4. Okay, and the arrival time are given as 1 millisecond, 2 millisecond, 3 millisecond, 4 millisecond. Fine. And burst time given as 2 millisecond, 4 millisecond, 6 millisecond, 8 millisecond. Okay. So now I am going to solve this question. Okay, and it's a very easy topic. Okay, nothing is new. If you have clearly understood round robin algorithm, SRTF algorithm, priority algorithm, then this concept is nothing. You will easily understand this one. Okay, so I'm going to start this. So at first, what we have to do, we have to draw the Gantt chart. Is it visible? Okay. From here, I am drawing the Gantt chart. Okay, what's wrong with the marker? Okay, so from here, straight. I am drawing the Gantt chart. So you see, the arrival time of process P1 is 1 millisecond. It means what? At 0 millisecond, none of the process have been arrived. So from 0 to 1, there is no process in the ready queue. Okay. So now you see at first millisecond, at 1 millisecond, process P1 is there. So here I will write process P1. And after completing 1 millisecond, another process comes, P2, at 2 millisecond. It means what? When P2 completes 1 millisecond from 1 to 2, okay, another process P2 will arrive. So how many available processes we have? We have P1 and P2. By the end of 2 millisecond, we have two processes, P1 and P2. Why P2? Because P2 arrived at 2 millisecond. Okay. So now you see, among the available processes, we have to select the process with the longer burst time. Okay. So you see, process P1 has already finished 1 millisecond. So it has remaining 1 millisecond. 2 minus 1 is 1. And now process P2 came. So process P2 has a burst time of 4 millisecond, whereas process P1 has the remaining burst time of 1 millisecond. So here we have to select the longer job. So definitely here process P2 will be selected because process P2 has larger burst time than process P1. So here I will write process P2. Okay, it means what? CPU is given to process P2. Okay. So, after running for 1 millisecond, now I am talking about process P2. After running for 1 millisecond, you see at 3 seconds, at time is equal to 3 seconds, you see process P3 also arrived. Okay. So here I will write process P3. So how many available processes we have? Process P1, P2 and P3. By the end of 3 seconds, how many available processes? Process P1, P2 and P3. Okay. And also you see at 2 to 3 seconds, process P2 has completed 1 millisecond. So how much remaining burst time is left? 3 milliseconds. Okay. Now you see, among all these available processes, we have to select which process? The process with larger burst time. So here P3 has the largest burst time because process P1 has 1, process P2 has 3 and process P3 has 6. So definitely P3 will be selected. So here I will write P3. Fine. So now P3 will run. So after running for 1 second at time is equal to 4, you see P4 has arrived. So how many processes are available by the end of 4 seconds? P1, P2, P3 and now P4. Why P4? Because the arrival time of P4 is 4 milliseconds. Okay. So now here, and also you see P3 has completed 1 millisecond. So 5 milliseconds are remaining for P3. So now among all these processes, which process has the largest burst time? Process P4. Process P4 has 8 milliseconds and it is larger than 5, 3 and 1. So here I will write process P4. Okay. And now you see all the processes have arrived. Okay. So after running for further 1 millisecond, what is the burst time left for process P4? 7 milliseconds. Okay. And you see still 7 milliseconds is larger than all the burst times. So here it means what? Still P4 has the largest burst time. So CPU will remain with process P4. So here CPU will remain with process P4. Okay. So again process P4 will run for another 1 millisecond. So from 4 to 6 now. It means what? Process P4 has completed 2 milliseconds. Okay. So how much burst time is left for process P4? 8 minus 2, 6. Here I will write 6 now. So still you see process P4 has the largest burst time remaining. Process P4 has 6 milliseconds left and it is larger than the burst times remaining of process P3, P2 and P1. So still processor will remain with process P4. Process P4 will further run for 1 millisecond from 6 to 7. So you see from 4 to 7 process P3 has run for 3 milliseconds. It means what? Now process P4 has run for 3 milliseconds. It means what? Here 8 minus 1, 2, 3. 8 minus 3, 5. Here 5 millisecond is left for process P4. Okay. Now you see out of all these available process, which process has the largest burst time? Process P3 and process P4. Okay. And here scheduler with short-term scheduler will select which process, P3 or P4. So in case of tie, generally what we do, we give the priority to the process with lower process ID, or we can say that the process which came earlier. So here we assume that the process with lower ID will be given more priority. So here you see P3 and P4 are the two processes with the burst time 5 and 5. So here what we will do, we will give priority to process P4. We will give priority to process P3. Why? Because P3 has lower process ID than process P4. Okay. So here I will write P3. So here you see context switching happened. So now you see process P3 will run for 1 millisecond from 7 to 8. So how much remaining time is there for process P3? It was 5, now it is 4 left. Okay, and now you see among all these processes, which process has the largest burst time? Process P4. Process P4 has 5 seconds. Okay, it's the largest one. So again, CPU will be given to process P4. Okay, and same thing, process P4 will run for 1 second from 8 to 9. So burst time left for process P4 is 4. Okay, and again you see, again there is a tie between process P3 and process P4. So process P3 will be given more priority. Okay, so here I will write process P3. So process P3 will run for 1 second. It means what, from 9 to 10. So 3 seconds are left for process P3. Okay. Now you see among all these processes, process P4 has the largest burst time. So CPU will be again given to process P4. So here I will write P4. Okay. So process P4 will again run for 1 second, 10 to 11. So now 3 seconds are left for process P4. Okay. So now you see, by this time, process P1, P2, P3, P4. So here, process P2, P3 and P4, all these three processes have the same burst time, which is of 3 milliseconds. And moreover, 3 milliseconds is the largest burst time till now, because process P1 has 1 millisecond and process P2, P3 and P4 has 3 milliseconds. Okay. So CPU will be given to the process with 3 millisecond burst time. So here you will see, since all these three processes have the same burst time, so in order to break the tie, what we have to do? Just we have to select the process with lower process ID. Okay. So here we will select process P2. So here I will write process P2. So process P2 will run for 1 second. 11 plus 1, 12. Okay. So now 2 seconds are left for process P2. So now you see, what is the largest burst time? 3 millisecond. And so the CPU will be given to process P3 because it has the largest burst time. Okay. So here I will write P3. And it will run for 1 millisecond from 12 to 13. Okay. So now 2 millisecond is left for process P3. Okay. Now you see, among all these processes, which process has the largest burst time? Process P4, because process P4 has 3 millisecond left, which is larger than 2 millisecond, 2 millisecond and 1 millisecond. So here CPU will be given to process P4. So here I will write process P4. Okay. So process P4 will run for 1 millisecond, sorry. So from 13 to 14, process P4 will run, and now the remaining time left for process P4 is 2 millisecond. So here I will write 2. Okay. So now you see there is a tie between three processes, P2, P3 and P4. Okay. So priority will be given to process P2. Why? Because it has the lowest process ID. Okay. So here I will write, okay, I will come this side. So here I will write process P2. Okay. Now process P2 will run from 14 to 15 millisecond. Fine. So how much remaining time is there for process P2? 1 millisecond. So here I will write 1. Now you see, CPU will be given to process P3 because process P3 has the largest burst time. Although process P3 and P4 both have the largest burst time, but in order to break the tie, CPU will be given to process P3. Okay, why? Because process P3 has lower process ID. So here I will write process P3. Okay, process P3 will run for 1 millisecond 15 to 16. So now 1 millisecond is left for process P3. Fine. So now process P4 will be selected because process P4 has the largest burst time of 2 milliseconds remaining. You see here. So here I will write process P4. So it will run for 1 millisecond 16 plus 1 17. So now 1 millisecond is left for process P4. Now you see there is a tie between all the processes. Now what we have to do? We have to give the CPU to the process as per their arrival time. It means what? Process P1 has the lowest process ID. Now CPU will be given to process P1. Here you see all the processes have 1 millisecond left. It means what? The largest burst time is 1 millisecond because except 1 millisecond there is no time is left. Okay. So it means what? Here all the processes have 1 milliseconds. So now CPU will be given to the process with lower process ID. Okay. So now CPU will be given to process P1. So here I will write process P1. Process P1 will run for 1 millisecond. Okay. Now process P1 is done. It had only 1 millisecond remaining. So here process P1 is done. Fine. Now CPU will be given to process P2. 18 to 19. Now 1 millisecond is completed for process P2. So here I will write 0 and now process P2 is done. Okay. Now here I will write process P3. (19 to 20). So here it's 0. Process P3 is done. So ultimately at the last process P4 is. So process P4 is also done. Okay. So this is the grand chart representation of this question. Longest remaining time first algorithm. Okay. And you see here from 0 to 1 second the process is idle. Because processor is idle, CPU is idle because it has not been assigned to any other process. Okay. So here you can see one thing that you might be thinking that the name of this algorithm is longest remaining time first. Sorry. The name of this algorithm is longest remaining time first, but you see here process P4 has the largest burst time. Okay. It means what? Process P4 was given largest priority. Okay. But despite having the largest burst time, process P4 is finishing at the last. Here you might be expecting that since process P4 has the largest burst time, so process P4 will finish first. No, it's not like that. Here you see LRTF algorithm means what? Here the response time of the process with the largest burst time will be less. Okay. It means what? In order to get the CPU, process with the largest burst time will not have to wait longer. Because here you see after 4 seconds process P4 got the CPU. Okay, so early. That's why. If it would have been a different algorithm like shortest remaining time first, okay, then what would happen? Then process P4 would not get the CPU so early. Okay, so it's regarding response time. Here process P4 has started responding early. Okay. So now From this grand chart, we can find out the remaining waiting time, turnaround time. Okay, so I know you can calculate those things, so I will only calculate the turnaround time and completion time of process P4, and process P3. Okay, let's calculate the waiting time of all the processes. Okay, so let me rough here. I think you have written all these things. Okay, so I am just roughing this part. Okay, so now you see here I am writing completion time, then turnaround time, then waiting time. Okay, so it's a separate question. Okay, fine. Just don't look at this part. Okay, it's a separate question. So now you see, what's the completion time of process P1? The completion time of process P1 is 18 seconds. Okay, so here you will write 18, not second, it's millisecond. What's the completion time of process P2? It's 19. What's the completion time of process P3? It's 20. Just wait. What's the completion time of process P4? It's 17. Okay. So now let's calculate the turnaround time. What's the turnaround time of process P1? What's the formula for turnaround time? Completion time minus arrival time. Okay. So just calculate it. For P1, it will be 18 minus 1, 17. For P2, it will be 19 minus 2, 17. For P3, it will be 20 minus 3, 17. For P4, it will be 17. Yes. So, yes. For P4, it will be 17 minus 4, 13. Okay. So, here I should draw the line, because I myself got confused while writing this. Okay. 20 minus 3, 17. 19 minus 2, 17. Okay. So, let's calculate the waiting time. For P1, it's what's the formula for waiting time? Turnaround time minus burst time. Okay. So for P1, it will be 17 minus 2, 15. For P2, it will be 17 minus 2, 15. For P3, it will be 17 minus 3, 14. And for P4, it is 13 minus 4, 9. Okay. So you see, here the process P4 has the longest burst time, but its waiting time is lowest among all the processes. So that's the main point of longest remaining time first algorithm. Here the process with the longest burst time has lowest waiting time. Okay. So I hope you have understood this. So now after this, I will solve GATE question. You just see this question.